God, I hope it caught you saying I'm simple right at the beginning of the video. I'm not sure if I got it or not. Alrighty, so today we're going to be tackling something called the cosine rule. Yesterday we found out how to find the area of triangles when we have a side angle side situation. It's very useful to us. And today we're going to find another rule that we get to use in non-right triangles that allows us to find information. Now what this is going to do is it's going to allow you to find either a missing side or a missing angle or two or things like that. So it's versatile. It's the cosine rule. So we can use the cosine rule to find information in triangles. It's actually called solving a triangle. It's when you find all of the other information. So I think right here on the board it says to solve triangles. It does. So, success criteria number 2. I'm doing my job. I'm reading the board to you right here. Using the cosine rule to solve triangles. So we're going to be able to do that today. Here I have a triangle that we have labeled triangle ABC with capital letters with side lengths lowercase ABC. Okay, so the general cosine rule, which mind you, you don't have to use the letters that I'm giving you. It's more about the positioning of the letters that matters. The general cosine rule says side length A squared is equal to side length B squared plus side length C squared minus 2 side B side C times the cosine of angle A. Not really a Pythagorean theorem. You can prove it using the Pythagorean theorem or derive it using the Pythagorean theorem. Now, again, sides A, B, and C, they're just generic terms here. Really, the way that I use the cosine rule is I allow the cosine rule to draw a triangle draw an arrow for me in my triangle. What do I mean by that? Let me show you. What I mean is that I started with side A, I ended with angle A. These are across from one another.
So let's say you were trying to find.
Well, hold on. Specifically, the angle A, in my mind, points at side A, and the arrow also points at side C and side B, like that.
Oh, I've seen this.
It's using these 3 sides, and the arrow shows you the beginning and end of your formula.
Whose principle is that?
It's just called the cosine rule.
No, there's a thing with all the pointy arrows that proves.
Oh, I don't know. Yes.
So let's say you were trying to find. Let's say you were trying to find the
side length B.
Yeah. So then it would be like B squared plus.
B squared equals
Or B squared equals, and then it would be cosine B, right?
Yes. So if you were trying to find side length B, you'd be saying this angle points at this side, and these would be the unknowns. So it would be B squared equals A squared plus C squared minus 2AC cos B.
So all right. So what's the relevance of this? Why? In what situations would this be used differently and used instead of the sine?
Well, the cosine rule can be used to solve problems involving triangles given 2 sides and an included angle, which is side angle side. Side angle side is what we did yesterday. You can use the cosine rule if you have side angle side to find another side. This would be to find the third side. So if you have side angle side, you can use the cosine rule to find the third side. Or if I gave you all 3 sides, angle, 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 then you could use it to find any, side, side, side. I'm sorry. Side, side, side. Because I knew what I was going to write next, you can use it to find any angle. That's what I was trying to say.
But you can also use the sine for the SAS, right?
What do you mean the sine?
Like the sine rule.
We don't know the sine rule.
What?
We don't know the sine rule.
Wait, what?
We don't know the sine rule.
Oh, wait, so what's the name of the formula thing we did yesterday?
Area of a triangle.
Wait, could that also be used? Wait.
Nope.
I'm confused.
Yesterday we used the formula 1/2 AB sine C to find the area of a triangle when we are given side angle side.
Oh, so it's about different things. Okay.
Right.
Cool. Got it.
This is used for finding sides or angles. So specifically, if you have side angle side, you can find the third side. If you have side side side, you can set this formula up in whatever order you want to solve for any angle you want. Cool?
Yes.
Awesome. And yes, there is a sine rule. We're doing that tomorrow.
Is there any?
Nope. It says find the length of BC correct to 2 decimal places. All right. I'm gonna give it a letter, and it really doesn't matter. Guys, you guys mind if I just call it X? Anybody care if I just called it X? Since it's the thing I don't know. And here is my arrow that tells me exactly how to set up my cosine rule. As long as you know that the cosine rule begins with a side length, specifically where the arrow is pointing. So it's going to be the side I want equals one of the sides I know squared plus the other side I know squared minus 2, one side, the other side, cosine of 42 degrees. Yes, it is on the reference sheet. Sigh of relief, right? And we're trying to solve for x, so how would we get x by itself? Yeah, so obviously you would just do the square root of both sides. And I'm not trying to write all that. What you're going to end up with is x equals, and if you use your, speaking of graphing calculator, did anybody in the room lose a blue TI-84 graphing calculator recently?
I'd be willing to take one.
I don't have it. I'm just curious. Did any of you lose a blue TI-84 calculator recently? Okay.
Wait, Chris, do you have, wait, yours
It
is
says I gained one. I got it. And it was blue and white.
Yo, is that calculator green?
Blue and green. It's kind of epic.
Where'd you get that?
The brightness,
Well, you should see how his case thing works.
Okay. No, hold on. I forgot all this was on video. Hold on. I'll drool later. Okay. All right. So you would just type this on a graphing calculator, do square root of, and just be really careful. Make sure you're in degree mode. And it says correct to 2 decimal places. It actually ends up being only 1 decimal when you're done. 8.8. It's like,
8.80.
yeah, you know IB doesn't care about the trailing 0, but you're not wrong. It is 8.80, but they don't care about that trailing 0. Yes?
Would we be able to put this in our calculator, like a program?
Okay, so you are not allowed to have any programs on the calculator when it comes time for the exam.
Okay.
So, but this is a senior question. But next year, senior year, basically the day before your IB exam, this year, everybody has to bring me their calculator, and that night I wipe the RAM of all the calculators. Well, and I set it back to factory. So I wipe everything, all RAM, all memory. The only thing it keeps is operating systems, and then I give it back at the IB exam.
So like if I put Flappy Bird on my calculator.
Yeah, Flappy Bird will be gone.
But hey,
Tetris will be gone. Your quadratic formula will be gone.
I thought, well, you could get like clip on it.
Yeah. Anyway,
Why would you remove Flappy Bird though?
it's not that I'm going after Flappy Bird. It's that I have to make sure that there's no programs on the calculator that would help on the IB exam.
But how does Flappy Bird help?
It doesn't. But I have to make sure there's nothing there that could help, so I have to wipe all memory. Because there's creative ways to hide programs on the calculator, just like you could do on a computer. So in order to get around it, you just reset the whole calculator.
What if I, per se, shifted the command to the RAM?
To the ROM or
The immediate cache.
Yeah.
That way my stored program.
I don't know. So if you're trying to solve for missing angles, remember I told you that you could use the cosine formula, the cosine rule to find any one of the missing angles, right? Well, all you'd have to do is manipulate this formula to isolate the angle. So let's just talk our way through it real quick. I'm trying to get the angle by itself. The first thing I'd have to do,
You're trying to get A by itself?
well, yeah, basically, if I was trying to get this angle by itself, I'd have to subtract this and this, right? Then divide by -2 BC, right? Okay. Well, that's what this formula says. Cosine of A is, I'm not sure if this is there or not, but it doesn't really matter. Yeah, it's so easy. You just subtract and then divide. And the reason why it's in this order is because when you divide by the -2, all the signs change. There. I'm going to be real with you. I don't know this formula. I don't think it's in the reference sheet. I just, what I do is I just fill out the cosine rule when I need it, and then I just solve for the angle. It's really not that hard to do. I am going to use this formula though in the upcoming work because why not? It is. Alrighty, so in triangle ABC, triangle AB is 7. Triangle. Side AB is 7. Side BC is 5. Side CA is 8. It says find the measure of angle BCA. That little hat symbol means angle. Time to draw a triangle. A triangle does not have 4 lines. Ah, got him. Alrighty. What do we know? They've actually called it triangle ABC, so I'm going to go ahead and name it. And the order of the letters is arbitrary. So there's ABC. The only reason why I'm doing that is so that way I have the ability to figure out exactly which sides and angles it's talking about. Side AB has a length of 7, side BC has a length of 5, and side CA has a length of 8. And we have been asked to find angle BCA. So the middle letter is the angle, so we're trying to find this. I'm just going to call it X because capital C and lowercase c look remarkably similar. And basically, I'm just going to fill out this formula. The only difference, the problem is when you use this formula, you have to remember that this angle is this side. But if you think about it, it still kind of works the same way. It begins and ends with it, if you want to think about it like that. So I go, yeah, this angle will end with that right here. I always think about the angle pointing at something. So I'm going to say cosine of x is adjacent across 8 squared plus 5 squared minus 7 squared all over 2 times 8 times 5. Well, when you grab handy dandy calculator and you do all the calculations, 8 squared plus 5 squared minus 9 squared or minus 7 squared over 80 equals 1/2. Yep, so cosine of x is 1/2. This fraction reduces to 1/2. So how do we isolate x? Yep, cosine inverse. X equals cosine inverse of 1/2. And we weren't told angles or radians, so I meant degrees or radians. So how about degrees? X is 60 degrees. In which 2 quadrants is cosine positive? 1 and 4. Is it possible to create a triangle with angles from quadrant 4? No. Then you never have to worry about a hidden second answer when you use the cosine rule. Because triangles, all the angles in a triangle are smaller than 180, right? But angles in quadrant 4 are between 270 and 360, and that's why. So even though cosine is positive in 2 places, it can't happen in triangles, in real triangles, right? So we go, yeah, this is the only possible answer because the other answer of 300 degrees makes absolutely no sense in a triangle.
Triangles can only be drawn in quadrant 1 and 2.
Yes, like because the angles have to be smaller than 180 because they all add up to 180. Part B of this question says find the exact area of this triangle. Hey, that's yesterday's material. Yeah, remember? Area equals 1/2 AB sine C. And remember, again, the letters A, B, and C here are just placeholders for the formula. This requires you to use side angle side. If you're going to use this formula, you're using side angle side. That means we're using this information. We will not be using the 7. So our area is 1/2 8 times 5 times sine of 60 degrees. And we're going to do this without a calculator. Oh, come on. Ah, see? Got him. All right, so 60 degrees. Yeah. 60 degrees is in quadrant 1. If it was cosine, it would be 1/2. And we're going to put a little 60-degree angle right here. What's always across from a 60-degree angle? A root 3.
There you go.
So sine here is root 3 over 2. So this is what, 20 times root 3 over 2? Or 10 root 3. That is the exact area of this triangle. This triangle, not this triangle. And that's it. Woohoo! Yay!